Hey everyone, so this next section that we're going to jump into is actually going to be a little bash through the bug crowd LevelUp7 CTF, and I believe that submissions for that are now closed, but we at least I haven't gone through it yet. So basically I'm going to be bashing through it, and you guys can see how bad I am at CTFs. And luckily, I've got the Brains Trust to help me out here. So everybody, welcome Maxim. Maxim is an employee of BugCrowd, and he actually created the CTF. Am I right, Maxim?
Yes, sir. Hi, everybody. My name is Maxim. I've been triaging here at BugCrowd for nearly 2 years. So some quick context about the CTF. Sort of with the last CTF I built for BugCrowd, which was graphical, I wanted to sort of show a lot of the stuff that's submitted commonly at BugCrowd that turns out to either be NA or out of scope or not reproducible, and sometimes even P5. And I kind of wanted to show how you could take those bugs, chain them together, and leverage it. So the reason I did that is because my fellow triagers and I, we've noticed that we would explain to a researcher why something was marked as such, and then we would wake up the next morning and they would submit, very same or dissimilar finding on a different program. So I felt that instead of rather explaining to someone, I'd rather demonstrate it and have them play the CTF and learn it for themselves.
Awesome. So the whole kind of idea behind the CTF was to be an educational piece about, being able to submit bugs that have a security impact, right?
Yeah, correct. Throughout the CTF, you'll see like a lot of tidbits, I guess you could say. There's some like tips, some stuff that I've seen in my triage work that I thought was pretty cool that I wanted to share with people. So yeah, that's kind of the gist of it.
All right, cool. Well, how did you want to kick this off? Oh, also, we didn't mention this, but from the previous talk, if you want to follow Buses Can Fly, he's on Twitter. So let me just make sure that I'm going to say this right by actually going to the Twitter profile. Yeah, it's Buses Can Fly. That is literally the Twitter handle. So twitter.com/buses, BUSES, can, CAN, fly, FLY. So definitely chuck him a follow. If you're into hardware hacking in any way whatsoever, you'll get a lot out of following him. So yeah. Anyway, back to the CTF. So Maxim, you're sharing your screen now, right?
Correct. Does everybody see it?
All right. So if anyone wants to follow on, although we're not accepting submissions now, we still have the CTF live, so you can kind of follow through. So I think Maxim's going to actually go through the CTF. Is that right, Maxim? And I'm basically going to ask stupid questions along the way, along with Sajib and Jay. So let's do it, Maxim. What's the first step?
All right, awesome. So I'm going to give a quick disclaimer. It's going to seem a little linear right now because I obviously don't have the time to, sit there and search, directly brute force, do all the things. So forgive me for that. So yeah, so when you load up the 07 level CTF, you get this page right here. You can type in brief and you sort of see the kind of the lore of the story. So long story short, basically there's an evil spy agency called Obelisk that's led by the evil matriarch. And they're trying to delete all the information related to COVID-19 using the WannaSpy ransomware. So our job is to infiltrate it. There was one agent that did, but however, we lost contact with them, but they planted something at /radio, which requires authentication for us to get to. So the first thing you would do is obviously start directory brute forcing. So you would pretty much come up immediately on /login, and kind of looks like an ominous page, really nothing to see here. Just like with everything, you'll check the page source and you'll see, it looks like a common bootstrap heavy jQuery. You have your CSS, but you have something here that's pretty not normal. So in terms of bootstrap, so when you open it, it actually does look like bootstrap, and that was kind of done to throw people off. But you can always modify custom JavaScript files, and that's sort of what I was trying to show here, is that even if the file seems to be like a default that comes with, the bootstrap installation, it's still a good idea to look through it. So you eventually start looking through it, and then you would look up for flag, or you would find flag, and So there's a small to-do note, and it says add secret backdoor to download app, because who looks in JavaScript files anyway? And you would get the first flag. And along with that, you also get an endpoint. So that's one of the things I wanted to kind of push on, is that, look for endpoints as well. Sorry.
Yeah. So when I first started doing that CTF, when I was just looking at it this morning, I saw the login page. I found the login page. I think if you go to /radio, so that's where the link is. If you go to /radio, it will redirect to login or something?
Yeah, that's correct. So I use the Laravel, which is like an MVC framework. So it just pulls up the view. So you think that it's redirecting, but yeah.
Yeah. So the first thing that I tried when I went to that is like some injections on the actual login page. And I kind of caught the login thing in burp. And I was like, surely the way past this is to get past the login, right? But it's not. It was checking the JavaScript files, right?
And that's kind of what I wanted to point to was, yeah, it's not always injections. So we could just type in like arbitrary usernames and stuff, and we'll see that's invalid credentials. Try to do like some sort of, it really won't return anything. So this itself, in terms of if you would submit a report like this, since there's really nothing being, obvious right now, they would be kind of deemed as a P5 or NA, because you're really not showing any impact. Obviously, once we start going through this, we'll start seeing the impact. So yeah, so you get basically a new endpoint, which is basically a secret communication. So if we browse to here,
just a quick thing while we're doing this. Sorry, just as a quick tip for anyone who's doing CTF, since I played a bunch of them, one of the easiest things to do is always search your burp logs for the word flag. You'll like a lot of them, you'll actually find missing flags and things like that. It just really does help. That's
actually a great tip. Yeah.
Yeah. That's actually how I found this flag too, because in I think it was the program brief, it said it says the format of the flag. So then I could just search flag in my burp history, and it came up.
Yeah. So actually, we could just try to do it live, because I have this proxying through burp. So
yeah, sure.
Yep. So sorry, my computer might be a little laggy because I'm streaming, but yeah, it's kind of lagging out. But yeah, we'll pull it up here, and you see it has 8 results. So if we pretty much look at the response, we'll find the flag.
Yeah, nice.
So yeah, so eventually we come up, it downloads this APK. So what I did was I have like the Android emulator running here with it installed already, so I don't install it on stream. So you can launch it, and hopefully it doesn't lag out. So it just looks like a pretty basic login page. And again, you could try doing, same thing. You could try logging in, but from logging in, you get, an error that the app is down. Try using the web. So along with, so I also threw in some Easter eggs that I've had throughout my bug crowd experience. So one of them, if you click right here, it'll have a dumpster fire. So I thought that was pretty interesting. So yeah, so eventually what the majority of people do, and this is another common issue, is that what we could do is we could just dump the APK and see if there's any, sensitive information in there. So what we could do is we could move it into here.
That is a very pretty shell.
Yeah, it helps. So the majority of the time, you'll find strings in keys in like strings.xml. So that's probably the first place where we'll check. And forgive me, I'm not an Android guy. So this was actually, I kind of wanted to bring this up as well while this loads, is that a lot of people think that when building CTFs, you kind of really need to know something like, really need to know it well. So for me, what I've learned though, is that when I'm building CTFs, I usually do it with technologies that I don't know. So for example, GraphQL and graphical, I did not know GraphQL at all. So that was kind of my breakthrough in learning how it works by setting it up. And the beauty of that is that you completely can go through all types of different configurations until you find something you like. So same with Android. Like I've never really built an Android app before, and this was my first time for the CTF. So it's kind of, nice. Yeah. So for anyone that's wanting to get into CTF. So yeah, so like I said, we can look into strings.xml.
So just as an FYI for all the viewers, basically Maxim's gone ahead and used APK tool. So that's disassembling the actual APK package, since it's just like a zip file, and it's going and trying to rebuild some of the code into a more accessible and readable object.
And just in case you weren't aware of this one, APK is the extension for an Android app. So the APK file actually contains app. Like if you're using a Mac, you might have .app or whatever. And the other thing is we're looking in strings.xml now, and we're looking for a flag. But the way that I actually found this is by using grep. So I did a recursive grep for the word flag again, like grep-r flag, and then the current directory. And yeah, this is how I found the next flag. But sorry, Maxim.
Oh, no worries. I'm really happy you guys are chiming in because you guys are definitely sharing a lot of verbose information that I'm sorry if I'm missing. And thank you, by the way. So yeah, so once we find the strings.xml file, we'll find the second flag and some little bit of background. The way that I kind of build CTFs is that when you find flags, it sort of means you're on the right path and you should keep going this way. So that's kind of how I like to, keep the player knowing that, hey, they're succeeding in some sort. So yeah, so once we find the second flag, right above it, we find this encrypted chat key. So, and that's another issue that we get a lot as triagers is that people would just dump the apps and they'll be like, well, here's the API key, figure out what it does. And a lot of times, that API keys can be public or, they're meant to be public and they have no security issue. And, especially with big companies, for them to chase down an API key like that, it can really take weeks or months. And a lot of companies now are at the point where they just ask for proof of concept, demonstrating active exploitation.
Actually, even as triagers, we push back on that now. So like if you find an API key, most of the API keys that you'll find are meant to be public. They're not meant to be secret API keys. So that's one of the things that we get a lot in the triage queues at BugCrowd is people submitting like API keys for things that are just meant to be public. So and then there's no context around how it could actually be used to provide security impact. So when we're writing reports, make sure that there is security impact there. You can't just report a string of random characters. You have to report how you can use that API key to do something that has a security impact. Yeah,
and quick shout out to key hacks. So if you ever have an issue with not knowing what an API key does, there's this community run GitHub. So it's key hacks. I'll throw it into the Discord afterwards, and it has a lot of API keys there, so you could and how to demonstrate active exploitation with that. So
yeah,
I agree. Also, show us a POC and how you can use it as well. That will really mean a lot to us and easier for us to triage, like to know what the issue is.
Yeah, for sure. So two Keeps just put a link to key hacks, and Codingo did as well, into the Discord. So yeah, that's a really, really great. It's the Streaks GitHub, and he basically like you said, he's got basically pre-built proof of concepts that you can use for different types of API keys. So it's super, super handy for demonstrating impact easily on bug bounty reports.
Yep, and your priority, if you don't demonstrate the impact and the company decides to go with it, in the rare case it does, you can be misprioritized, it can be called a P3 when it could be a P1. So always show a proof of concept and show the impact.
Yeah.
So as you mentioned, APK tool decompiles the app. However, it'll decompile it into Smalley, I've noticed. And so as you'll see, it can be kind of, so let me go into like the, sorry, I haven't done that preparation. But anyway, so Smalley's kind of hard to read. It's so what I like using to actually get it into Java code is JADX GUI. And what we could do is also run it against the communications, the same against the APK as well. So now we'll see it pop up.
Can you give us a little thing about what JADX GUI actually does, what it is?
Yeah, sure. So basically what it does is, so I should probably just show an example of how the Smalley looks. Because I could show it side by side, which will probably clear it up a lot. Basically looking for main activity. There we go. Cool. So main activity, that's Smalley. So as you can see, this is sort of Smalley. And if anyone wants to kind of give a little bit more verbose explanation about it, because mine will not be the best, it's a little bit harder to read. And so compared to JADX GUI, which will actually decompile it into Java, we could see the same. I'll bring them up side by side right now. We could see the same code. Sorry, it's taking a little bit. So we could see it, but this is actually in Java, so it's a lot easier to read. For me, at least, because I come from a Java background. And
So is Smiley a language?
So it's actually a compiled format
Right.
for some sorts of Java, basically.
Got it. Got it. Well, yeah, that's going to be way easier reading Java, isn't it? Actual Java.
Yeah.
yeah, so you could see like, so this is a lot more easier. So you actually see the functions now. So yeah, so as shown, we got the encrypted chat key, but again, we don't know what to do with it. So when we open this in Java, though, we see a request being built out to a different endpoint now, and with the HTTP header that's using that key, and the header's name is encrypted chat.
Ah.
So if we would actually look here, I could probably just FA694R. Yeah, so sometimes it won't even show the pattern. So like, it's really just easier to use JADX GUI, in my opinion. So yeah, so now we've stumbled actually upon 2 endpoints, and we can go to this one first, the forgot password one, because that one's always usually juicy. Try to get someone's account. So so we could browse to forgot password. And again, now we don't know username. So this is another P5 we see on Bugcrowd a lot. It's username enumeration via brute force. So it's like, if I type in an arbitrary username, I'll see, no registered users with that username. And while, in a pen testing scenario, that could actually be a worthwhile attack, it by itself is a P5, unless you chain it with something, which we're going to do in a second. So as you can see, nothing really interesting came out of that. So now we could try to browse to this endpoint, the chat endpoint. And upon browsing, we'll see that we have the invalid key. So as mentioned, we got the key earlier, so we need to set it with the header. So I found the easiest way to do this is to use burp's match and replace with the header. So we can add a new HTTP header. So as shown in the code, it's going to be called encrypted chat. So we could throw that in. And then the API key itself,
is that the one that we got out of the strings?
Yeah.
Cool. So what we're doing here, just to reiterate, is we're changing our HTTP request that we're sending to the application to contain a secret header, which we found within the main activity Java file. And we are adding the secret key to the header. And the secret key was what we were able to find from the strings.xml file within the APK, right?
Yep, that's correct.
Yeah.
And to go back to the Java code, we could see it being used here because so it's basically building out a new request, and we see that the header is using encrypted chat and it's using the key. And then so you might be wondering what the key is, and we see it, we define it here. So basically it's telling it to grab the encrypted chat key from strings.xml. And if we look here, it's basically encrypted chat key.
Right.
So yeah, so if we didn't do the match and replace rule in burp, we basically have to intercept every single request and add it. And that could be a little bit tiresome, especially if you're, if there's a lot to do. So after we add the rule, we could try refreshing. And now we're in. So yeah, and to kind of show the, we can actually see it being auto-modified. So it's actually adding the header. So we can see it not here, but then when it modifies it, it adds the header.
And that's on every single HTTP request going out of burp, correct?
Correct, yeah. So
that would also include things that aren't in scope of that, just as an FYI to everyone.
Yeah.
Awesome. So yeah, so this is kind of where I was trying to build the challenge in kind of realism terms, but again, since it's spy themed, I kind of wanted to throw some spy things around. So once you come up on here, you'll see a lot of the message is kind of like garbled or scrambled. So this is kind of really common in CTF. It's using the ROT13 cipher, which is basically moving every character like 13 characters forward. So you'll see it a lot, and if you play CTFs a lot. And so what we can start doing is basically if you just go ROT13.
The ROT13 cipher, by the way, all it does is rotates each character 13 letters forward through the alphabet. So an A would become an A, B, C, D, E, F, G, H, I, J, K, L, M, right?
Yeah.
And then if you do it again, obviously because there's 26 characters in the alphabet, then you end up back at the first character. So the cipher works two ways. You can do it and then do it again, and then you end up back at A from M.
Yeah, so you won't really see it used in bug bounty much, but I thought it was just pretty cool to throw in because of this whole spy theme going on. Yeah. So, for example, we could show an example of the first message. So you kind of see it's like a picture of a cat, and then it says your RPJ. As soon as we post it in here, it'll go to meow. So, yeah. So what we could do is we could start throwing in the messages in here. So I'll just use a few dashes as a delimiter between each message. And then so eventually we get the conversation. So basically, it looks like one agent's asking the other, hey, have you got our mission yet? And it's the other agent's telling him, yeah, we do check the mission list. They caught some hack agent as well. And he's basically saying, that's crazy. Anyways, check out this dope giraffe I saw at the zoo the other day. And the other agent's being polite and telling me it's cool when he really doesn't care. So what you might notice is we have usernames though now, and the forgot password endpoint was that's what we needed, and that's what we were missing from the piece of the puzzle. So what we could do is we could start with, for example, agent tall, and we can go back to the forgot password endpoint. So. And we could tell agent tall, looks like there's no one registered with that name. We could try with the next agent. And so we get a security question. So it's, what is the name of your favorite lion at the zoo? And a lot of people were like trying to name different kinds of breeds of lions, or, like famous lion names. So if you might notice earlier, there's a picture of this giraffe, and there's a reason for that. And that's another tip with CTFs, is that a lot of time when you see something that might look a little bit random or misplaced, it's there for a reason. And so a big thing we have at BugCrowd, or it's not big, sorry, a VRT category we have is geolocation in the XF data. So each photo has like some metadata, and that could be like the camera that the photo was taken with, where the location was. And that's normally not an issue if you're up, if it's where, so for example, we come across this a lot in triage, is that if there are no other users that can access your profile picture, and so there's some apps, like for example, training apps, where you're really it's only you, there's really no risk. However, in the case where other users can access the pictures and the XF data is not stripped, that's when bad stuff could start happening. And it's not necessarily like end of the world stuff, but doxing can come out of it, and just a lot of, like, I'll show right now how to kind of leverage what can come out of it. So so a cool website. So you can just type in XF data viewer on Google. You could use the XF tool on Linux, whatever you want. So this one's like a really popular site, the Jeffries image metadata viewer. So what we could do is we can copy the address of this image. We could throw it into here, solve the CAPTCHA. It's funny, buses can fly, and it's asking me for a bus.
This is the real challenge.
Yeah, especially if your internet's not that well. I don't know. Is that a bus? I think so.
Yeah, I think that's a bus. I'm glad we can help you out on this, CTF.
I wouldn't have been able to do this without you guys. Thank you. See, I'm telling you, it's like, please try again.
You must be really suspicious. Have you got
I think I'm a bot. So.
Oh, come on, Google.
It's gonna keep going. Okay, I think we're good. I always run into this, so it's so common now. That's why I always recommend using VPS when testing as well, because a lot of sites will, you'll start getting CAPTCHAs popped up everywhere. So if you're using your real IP, okay, I almost clicked that, but I think we're good. Okay, final. So we view the image data, and so we find the third flag. So. Nice. Yeah, and like I mentioned earlier, if you find a flag, it means you're on the right path. Along with finding the flag, we now find the latitude and longitude. And to kind of go back to this question, it says, hey, what is your name of the favorite lion at the zoo? So that kind of sort of hints like, hey, you have the coordinates where this picture is taken, and it looks like it's been taken at a zoo, unless someone has a giraffe. But so we Google the coordinates, and lo and behold, the San Francisco Zoo pops up. And So now this is where you start doing some OSN, and you start going, San Francisco, Cisco Zoo, lion names. And for this challenge, for this part, I didn't want to make it super hard. And based on how you Google it, this is usually on the top page. Sometimes it's first, second, third, as in my case. You see it here pop up twice. So you'll come across this article that Jahari, the beloved lion, died at the San Francisco Zoo. And it's asking you what is the name of your favorite lion. So you can type in Jahari and boom. So,
hey.
Yeah. So, so this is sort of where, when you're building a CTF, you kind of have to keep in mind that a lot of people are going to be playing simultaneously, and you can't really have people change the password or else no one's going to be able to get in. So it kind of had a static password it would kind of return to you. So we have the password, we have the agent name. So it's time for us to log in.
Awesome. By the way, if that's how your forgot password reset works, you got problems.
Not good. So yeah. So
nice.
Yeah, so we log in. We see this totally not sketchy mission list. And a little quick thing I wanted to add in here, like I mentioned, we throw in, I threw in some tidbits that I've noticed a lot, misclassified at BugCrowd. So we have this really, we have a P4 and P5 variant of this, and that's basically the session's not invalidated on logout, both client and server side. So client and server side is the P4, and that's basically to give you some context that when you log out of an application, the application is responsible for overriding the cookie, the session cookie in your browser, and that's what's causing you to log out. So in this case, we see this log out button right here. If we click it, we see nothing happening. And if I was at a library or somewhere that's using shared computers, I would have to go in and explicitly modify my cookie, my session cookie. And, a lot of people that are not technical, they won't know what to do and they won't be able to do it. They'll most likely just close the browser and move on with their day. The P5 variant, though, is what it gets submitted is that the cookies are still valid on the server side. So we click log out, we're logged out successfully, but the cookie, you can still reuse it in a repeater. And the reason that's a P5 is because we would need proof of concept that demonstrates remote exploitation. So a very common vector for this could be XSS if the cookie's not using the HTTP only flag. But then that issue comes in is that that's kind of already factored into the P3 priority for XSS. So that's a really, really commonly missubmitted bug. And researchers are always wondering what's the difference. And the difference is that you see that the session cookie is not overridden client side. So we can keep clicking log out all we want and nothing's going to happen. So yeah, so eventually, as the brief mentioned, there is a radio once we bypass authentication, so we can go into radio. So while this is loading, so this was actually, so what a lot of people, well, a lot of pen testers would probably know is that you can exfiltrate data via ping. And I actually had it built out where you would actually have to input your IP address and run an ICMP listener, and you would actually get this message. It basically looks exactly the same. But the issue I thought was that not a lot of people have servers, so I didn't want them to, start mucking around with their router settings, for example, and enable it to receive pings. I kind of felt that would be a security issue. And the second issue was that every time they would actually activate this, a new thread would open to send them the data. But then I realized that if there are 100 people playing, then that could basically cause a denial of service to the server. So that's kind of another thing when building CTFs is that you can try being realistic, but a lot of times it won't work out. So yeah, so eventually you see this data, and it basically tells agent, I've noticed that Obelisk hides missions and images. So that's sort of a hint to steganography, which we're going to get into next, and basically check out the target list, and we get the last flag, or not the last flag, I'm sorry, the fourth flag. So along with that, I kind of threw in a cool article that kind of shows how to exfiltrate data via ping, and it actually gives a Python script you can use. And you would actually use this more in like pen testing. For example, you have like an RCE or something, and you want to like exfiltrate the data, because there might be like egress filtering rules, so you can't send a shell out. So this is sort of a cool way to do it. Yeah, so like what the radio told us is check out the target list. Oh, sorry, if anyone wants to say anything, I don't want to interrupt. All right, everything's good? Okay, cool. So yeah, so we get a secret component, all the bugs. So we can now go back to the dashboard because that's, oh yeah, sorry, that's a cool four-part page I did as well. Sorry, log in. But yeah, so as you saw, we were automatically logged in because, again, the logout button doesn't work. So just to kind of reiterate on that again. So we go into the target list, and it loads all the confirmed hack agents that Obelisk has managed to get their hands on. So we might see a familiar one or two familiar ones. So yeah, so apart from this, so when you get to this, usually what I like to do is view the page source. You can actually just open up in Chrome DevTools as well, and you could just go to sources, and it'll basically load everything that's here. So you see this agent folder along with all the pictures. So if we'll double click it, should open in a new tab, which will prompt us, which will automatically download the image. So yeah, so kind of going back to the view source, what someone would notice is after you would basically try. So there's a tool called StegHide, and there's a lot of tools that you can use to extract stuff from images. So after you would sit there and you would realize that none of these images have anything hidden, but what you notice is that they kind of go in sequential order. So what I could do is I can open up Burp, and I really hope this won't lag me out. And by default, Burp won't show like PNG or like image files. So what I could do is just click Show All. So you'll see now in my history, some Twitter stuff is loaded there. So what I could do is actually just add this to my scope real quick, so this is a little cleaner. Yeah, so show in scope, and then so let's. Oh wow, I'm gonna reload it real quick so we can see any images that will load. That's strange. Let me see. See if that fixes it. No, that's beside it. Okay, sorry. So eventually what happens is that you would see, you would see kind of like what you saw in the view source. So it kind of goes in sequential order. So what you could do is you could send a request, and now you can intercept it. So I think the issue is that I think I'm using like this the new Chromium that's built into Burp, and for example, and it's not really loading my so let's see. Okay, cool. So we got a request. So what we could do is we could send it to Intruder, because what we could do is we could, like I said, it's in sequential order. So what we could do is try brute forcing the agent number. So we can add our payload marker there. When we go to payloads, we can go to numbers. And since we already know agent, we see agent 9 right here. So we know it starts at 10, and we could do 10 to 100, for example, and step by 1. So we send out a total of 90 requests, 91 technically with the first one. So you see that we can then filter out by length, and we see payload number 87 pop up with agent 87, and the response length is way different than the rest. So we can use that as a baseline.
I just want to, do you mind if I just step back a bit and describe what's happening in Intruder? Because I'm aware that some people might not be totally aware. So Burp Intruder is a feature of Burp Suite that allows you to basically send a whole stack of different requests where you slightly change one or more parts of the HTTP request on each time. So what we've done here is the payload that we're changing is the so each image had a file name that was like agent and then the agent number after it, .jpg, as you can see there. And those two little funny S-looking characters, I'm sure they have a name, but I don't know what they're called.
I call payload markers or payload positions.
The what? The
payload marker.
Yeah, payload marker. So basically, wherever those symbols are around, so in this case, just the number, that's the spot in the HTTP request that will get replaced by the payloads that you provide to Burp. And then we went over to the payloads tab, and the payloads tab, we actually defined the payloads that were going to be used. So that could be anything. That could be any text, any string, any whatever you want. But in this case, we just chose to use numbers, every number from 10 to 100. So then when you run the attack, it will basically send the same HTTP request, but it will just update the number in the file name each time to be like 10, 11, 12, 13, 14, 15, 16, all the way up to 100. And then it shows you a little table with all of the requests and all of the responses. So it's really easy for you to see if there are any images there that you can get. So in this case, we've got one, right, Maxim?
Yep. Yeah, so we found
sorry, just one last thing.
Yeah, sure.
Just to add on to that, remember that Burp Intruder is a really good way of automating things, and it saves you a bit of time from having to program, the brute force it yourself. But while that's actually happening, do remember that a majority of the systems that you're testing are prod systems. So don't go brute forcing, a million requests on them, because you're probably going to start disrupting service. So exactly as Maxim's showing, the request engine, you can modify the number of threads and the amount of pause you should have and things like that. So please do take a look at that before you actually kick off some kind of fuzzing with Intruder, just because you might actually take something down, which could cause massive issues to companies.
Mm. And also that feature, the Intruder feature, is available in the free version of Burp as well as the paid version. But in the free version, your requests are throttled, so they just go a bit slower.
Yep. Quick thing, if anyone wants to say anything, please interrupt me because I have you guys on my other monitor, so I might not see it. So feel free. Yeah. So like Lucas Rajib explained, yeah, it's really good. Limit your requests because that can also get you some banned from some programs because some people are really, really sensitive to that because it could take down the server, and that's not cool for everybody involved, especially if it is a production server. So yeah, so we see Agent 87 has a huge response length, and we can filter out each by clicking the column name. So like, you know, if you were like doing directory brute forcing, you wanted to see every 200, you could probably just click the status right here, and yeah, so on. So yeah, so we see Agents 87. What we could do is we could do copy URL because it's an image, and like I mentioned, stack height is going to be in use, so it'll download the image. So yeah, so quick thing, I'm going to quickly go into, because I haven't set up stack height for OS X, it's kind of got to install a lot of stuff for it. So what I'm going to quickly do, so I'm going to quickly download it to my, so cool. So yeah, so if we go back to the radio real quick, I'm going to clear up some tabs so it's a little less confusing. And to quickly view it, we can just look at the page source. And so we have a secret here. It's pwn all debugs, basically. So what we could do is we can run stack hide. So basically, stack hide is this tool. You'll see it used a lot in CTFs mostly. I've not really ever, I don't think ever came across it on a bug bounty platform.
I'd be amazed.
Yeah, on a program. Yeah. So I think that's definitely a P1. No, I'm just kidding. So yeah, so we can run stack hide against the image that we just downloaded. So using these flags. Actually, let me clear that so it's a little distract SF agent 87. So yeah, so we can enter passphrase. Usually, stack hide will always prompt for a passphrase. Usually, sometimes it won't have a passphrase. So if we type something in, it'll just basically say, "Hey, you can't extract anything." And a cool tip with stack hide is that I've noticed it works with JPEG images only. If someone wants to correct me on that, so that's kind of my tip when playing CTFs is that if it's a JPEG image, I'll try using stack hide against it. PNGs, it doesn't seem to work. So yeah. So yeah, so once we get in, we can use this pwn all debugs, and so we see that console. We got console.txt was written to the disk. So now we can look at console.txt, and so we get in. It says, "Hey agent, as ordered by Matriarch, I've created a backdoor console that will allow us to launch WannaSpy when time is right. We're not worried about anyone getting in since they have to go through many doors to actually get in. Once you're ready, you will find that console lives on port 3389." So quick thing. This is a hint for port knocking. So port knocking is more like obscurity or security through obscurity. It's sort of where you could basically have a port. You can have firewalls against a port, but when someone knocks a certain sequence of ports, the port will basically open up. So a lot of times, you can use it to hide SSH, for example. And if you know the sequence of ports, you can open it up, or you can use it pretty much with any service, which you'll see right now. But with port knocking, you will need to know the sequence. And so to figure out the sequence, once you go back, like I've mentioned, you would, if you were doing this organically, you would be downloading every image and you would be looking through every image. So for example, we can use this first image. Once it downloads, we'll open it. And we'll see, like right there, a number 1337. So we can go along this. I kind of made it a grid and to kind of, so I'm just going to do two images because we're kind of running short on time. But so we get the second image, and it's right there in the corner. So 415. So basically, what eventually happens is you will get 4 numbers, and again, like I said, sequence has to be the correct order. So you could use this like a permutation tool. Basically, there's a lot of scripts on GitHub that will do it for you. They'll start knocking different ports, and the reason is because you see here it says it lives on 3389, but if I go here and 3389, you'll see that the connection is refused. So the port's not open. So eventually, after you run the script, you'll it'll open up the port. So the correct sequence is it's, let me do it real quick. Now if we run, so now it shows that it's open.
That is so cool.
Yeah, so let me see if I can go through my history. I guess I did somewhere else. So basically, yeah, so now it's open. If I do it on my server, for example, right here, you'll see that it's...
I think I missed it. Was there any hint that this was actually port knocking that was meant to be used?
Yeah, so...
It's inside the text.
Yeah.
It's kind of basically saying you have to get through many doors. I thought doors and knocking was sort of... I was going to use ding-dong ditching, but I didn't know if that was sort of like international or only something that happens in the US. So, like, I try my best. And again, and then throughout the time, people started kind of dropping hints throughout the CTF.
Yeah.
So, yeah, so we get in. So once we get in, it said it was a secret console, basically kind of gave a tip, and we could try connecting to it. Like, you can try connecting to it with NetCat, basically it would just hang, and then you could try going into web. And you see it loaded up now, and it'll tell you, hey, greetings, Obelisk agent. Welcome to a secret command and control that will be used to launch WannaSpy. At the current moment, we're still building it out. So here you would either do a directory brute force, or you can actually look at the HTTP request sent, and you'll notice something really peculiar if you've worked with the software before. And like Sajid mentioned, this will send it basically to every single port as well, not only on HTTPS. So if we look at the response, we see that the server is using Worksuit and Python 3.8.2. So if you do some basic Googling, you would come up across the Worksuit console, which is like a debugging console for people writing Flask apps, for example, which is what this is written in. And that kind of makes it a lot more easier to debug. And usually it comes with the debugging pin, but there are times you can look up, there are disclosed reports where, sometimes the debugging pin's disabled and, now you have full, basically, control. So we'll go into console. And yeah, so basically now we have an interactive console where we can execute arbitrary Python code. So yeah, so if you get here, your heart should be running. At this point, you should report it. I just want to make a disclaimer of that. I mean, I wouldn't really recommend trying to, pop a reverse shell and trying to get a privilege escalation. This isn't the OCP. If it's in a bug bounty, if it's in a bug program in the context of a bug bounty, the customer would not really appreciate if you did that. So there's a lot of modules in Python that we could use to execute code. I'll just go basic with OS. So now we could do, so with OS, for example, if we try to execute something, it will just return the status. So like we'll see 0 because it works. But to actually read it, we could use popen. So if we do, it'll return the actual output. So again, this is where you would get a reverse shell. Like, I figured it would be a lot more easy to read, but because we're kind of short on time, I don't have a one-liner prepared. I'll kind of just go through where the flag would be. So here you would see, so in the user's home directory, which is agent0x07, you would see the flag, and it's somewhere here. I'm just not catching it right now. I'm just it's right there. So that's the last line. So yeah, so that's the flag. So a lot of people at this point, because again, with classical CTFs, here's kind of where you would try to go for a privest, such as a kernel exploit, try to get root. But I kind of wanted to show that you can kind of, use this to kind of exfiltrate or to kind of read data and to kind of connect everything in a loop. So eventually you start enumerating the system. There's a bunch of cool like Linux privest scripts that will really just sit there and just completely dump all the useful information. And then you'll come across the op directory where you'll find something interesting. So you'll find basically something called passwords.txt. You could also use like find, for example, and come across this. So once we open up, we can try to read the contents of passwords.txt. And let's expand it. So basically, it says matriarch has asked me to store everyone's plain text password, right? Which is the best idea in the world, in case we forget them. And this is another thing I see. I've seen this with CTFs. I've actually seen this in the bug context. Just because something's inaccessible from the web root, it doesn't necessarily mean that people can't get to it. For example, XXC with XXC, you can have file read with local file inclusions. So a lot of times, you could read, like, for example, the database where the database creds are stored and kind of go off that. But again, at that point, I would stop all testing, submit it, and then ask for permission to go forward.
Yeah.
So yeah, so we see these plain text passwords right here. So we see the one and only matriarch, and we see her password. So we can go back to this login, and like I mentioned, it's gonna be kind of hard to log out. So what we could do, oh, yeah, it worked. I guess our session might have expired. So now we could try logging as matriarch. So use this password. So yeah, so once we get to matriarch, we see something different. We see a big red destroy button, and no one could resist pressing that. So when we press it, we get to that, and we get the final flag.
Awesome.
So to kind of give a quick summary, I kind of try to blend realism and like CTF together. I've noticed in the last year or so, probably even before my time, a lot of pen testing has been now mixing with bug bounty, especially with Bugcrowd having, these new type of pen testing programs out there. So, you'll get a lot of pen testing, and a lot of stuff that you find in pen testing that would be really, useful in pen testing reports sometimes get P5s at Bugcrowd. And, some people get annoyed with that. So this is sort of how I try to show, something that could be a P5 could be leveraged, all the way to an authentication bypass, all the way to remote code execution, eventually to you saving the world. So that was the LevelUp CTF.
That is so good. That CTF was great. I really, really enjoyed the walkthrough. I wish I actually did it. And it was really cool to see port knocking come through. I didn't actually know how much port knocking is used these days in production, but I definitely have used it in a company that I used to work for to keep some admin dashboards safe from prying eyes, but still make them accessible to people. So yeah, it was really cool to see that, and the whole CTF was really cool. It looked great. I mean, I'm blown away, and I would love to speak about it more, but we're actually running out of time a little bit because we've got our next awesome event coming up. Sajid, would you like to do the intro?
Yeah. So yeah, our next awesome event is actually with WISP. So we're going to have a panel with all some of the prominent women in security. And they're going to kind of go and answer some of the questions and have a few discussions about some of the problems and things that they see, and how they're going to be going about doing things and how the future is going to look too. So feel free to go ahead and pop your questions in Discord if you have any. And yeah, well, we're looking forward to a really nice discussion.
Yeah, and I just want to say thank you, everybody, for providing information. I know I missed a lot of key parts, so thank you, Sajid and Luke and Jay, for being here. So before I go, I'd like to give a quick shout out to Got Milk. He is basically like the founder of VulnHub. That really inspired me when I was first starting to play CTFs and vulnerable machines, and it helped me a lot during the OSCP. And the second person is John Hammond, which he also deals in CTF. So he has the CTF Katana on GitHub, where you can find a bunch of cool information about CTF, such as like different rot ciphers and everything that's really been used in CTF. So yeah, if you want to ask any questions, I'm always in the Bugcrowd Discord. I'm always down to play some CTFs, do some VulnHubs, and yeah, thank you everybody again.
Yeah, and to plug that one, yeah, vulnhub.com is a great place to learn as well, because as what I can see from the CTF that Maxim did, there are some VulnHub walkthroughs that you could actually play like this one, and then you need to like get root to get the flag, and then there's also, as what Maxim said, Got Milk, he has some write-ups as well in his blog, and in fact, I've learned from him because he did some good write-ups about Linux privilege escalations in his blog, and he got a lot of awesome stuff in his blog. So I would really recommend to read his blog.
Awesome. Well, thanks so much, Maxim, for coming out and actually giving us this walkthrough. It was awesome. And yeah, let's transition to the next.